So after demonstrating things in the practical level, what to click where and where to find what, let's go over a few definitions. I hope it will make things clearer than if things were not understood so far. So what is the DMA? DMA is a mechanism where data is transferred between devices without involving the CPU directly. Okay, so here we have the CPU. In regular cases, the communication goes through the CPU to take requests, to manage power events, and so on. In DMA, we create a direct channel between the PCIe device and the memory component, mostly RAM, but it can also be a ROM, a hard drive. And via the DMA controller, you can create data transfers without involving the CPU. There is another component called IOMMU. I won't elaborate too much about it, but we have an interesting research I will talk about shortly. So we said this is DMA, and there are different types and methods in order to perform DMA. So we said that we want to keep the CPU as much as we can out of the transfer, out of this operation, for both faster transfer and to reduce the occupancy of the CPU. Let's say the default or classic DMA method is polling. During polling, the CPU keeps asking the process or the driver, are you done? Are you done with the DMA? And if the answer is no, then it moves to the next iteration or next operation. And then it asks, are you done yet? And if the answer is no, and so on and so on. And basically, it's quite straightforward. The CPU keeps asking, are you done? No, are you done? No, until the answer is yes. And then the CPU knows that the DMA transfer has ended. It is both time and resources consuming for the CPU and the DMA process. So another option to perform this operation is with the interrupt method. So the PCIe and the RAM facilitate the connection with the locked buffers, and the program executes and all the memory is flowing. And when the transfer is done, an interrupt is raised using an interrupt handler, saying to the CPU, the transfer is done. So give us whatever you need to order, for us to continue or to synchronize other components within the computer. But it takes less resources, harder to implement, but it takes less resources. So these are the two methods for conducting DMA. And there are also different DMA types. Okay, so blocking and non-blocking is the non-DMA ways to transfer data. There are DMA with interrupt method and polling method. The question which is faster. So one may think that interrupt is usually faster. However, it is best to try both. I mean, if you can, each device and each operating system works differently. So one may work faster with this, and another work faster with the interrupt. Someone is asking, will I share my slides? I can. Send me your email and I will send it to you after the presentation. Okay, so we talked about how the CPU is involved in the DMA. And there is another question when you plan a DMA for how the memory buffer is looks like, or what kind of memory buffer do we want. So there are two types of memory buffer. One is contiguous, and the other one is scatter-gather. In contiguous DMA, we get a single segment of memory allocated, and all the memory is being written and deleted and so on here. In scatter-gather DMA, there are multiple non-contiguous blocks of memory allocated and locked. The advantages. So contiguous is more robust. Let's start from the top. Scatter-gather is more robust, okay? Because if we need a large buffer of DMA and we set it to be contiguous, and this memory section is not available on our memory, then the DMA will fail. So contiguous is scatter-gather is more robust. Contiguous is less robust. We saw that it easy enough to allocate a scatter-gather memory section. However, it might be more challenging to cope with or to manage it. So these are the main differences between scatter-gather and contiguous, and these are the again the visual representation of each DMA type and how it looks like. So we have contiguous and scatter-gather. I want to show you research made in our R&D team, by our R&D team, for comparing DMA performance. You can find it on our website, Media Blogs, and this is the headline. Basically, what they've done is taking the same architecture. Okay, we have the hardware and the operating system here. Trying different kernel versions, trying different interrupt types. Okay, whether it's polling or interrupt handler driven. Tried to work with the IOMMU component instead of the DMA controller, and got some interesting results. And tried it with ARM and non-ARM platforms. And we have a summary of the conclusions. I must say, it is a very, very, very specific outcome based on our specific devices and their specifications. What I want, if people want to get, I don't know, inspired or take from it, is to try themselves. For example, we saw that large buffers doesn't necessarily mean a faster DMA. Okay, there is an optimum point. After it, the performance diminishes. So we have the research here. If you're interested, we have two accompanying blogs regarding polling versus the interrupt and scatter-gather and contiguous, elaborating on these types of DMA. So you can find it on our website. I don't want it to take too much time from us, from what's left.